This is Module 11, the third video, and we're going to go through an example. So the example reads, is there a relationship between the amount of time it takes a student to take a test and the score the student earns on the test? So 33 students took an exam, and the amount of time as well as the score on the exam was recorded for each student. So I have the data set here in the lecture guide. So for example, one student took 30 minutes and got a score of 100, another took 41 minutes, got a score of 84, and so forth. I'm going to go down, down, down to question A. So question A asks just for the explanatory variable and the response variable. In this case, the explanatory variable is the time the student took to take the test, and the response variable is the student's score on the test. So what are the observational units? The observational units are the students. We observe each student and we write down 2 pieces of quantitative information about each student. How many are there? It told us that there were 33 students. Is this an experiment or an observational study? It looks to be an observational study. Okay. Part D then asks us to put the data into the least squares regression applet. So this is an applet that you're going to be using for the remainder of this course, and then we're going to create a scatter plot using that applet. So you can go right up here and you can just copy the entire data set, including the labels at the top where it says time and score. So I'm just going to copy that. I'm going into the Rossmann Chance applet collection, and you'll see right in the top left, there's the least squares regression applet. So I click on that, and you'll see in here it already has some data loaded. But if you hit the clear button, it empties that whole data set out, and you put your cursor inside the empty box and press paste, and it will put our data set in there. You can scroll up and down with the little bar here, and you can see our data set. When you click Use Data, it will now plot our data set. You'll notice along the horizontal, it says time. So that's the time the student took to take the test. And along the vertical, it says score. So that's the score the student earned on the test. Okay, so there's a screenshot of my data set in the Rossmann Chance applet. It asks which variables on the x-axis, which variables on the y-axis. Remember, your x-axis is always going to be your explanatory variable, and your y-axis is your response variable. And that is what happened here. We said the explanatory variable was time, and it is on the horizontal axis. We said the response variable was the score, and that is on the vertical axis. All right, part E asks us to describe the direction, form, and strength, and asks if there are any unusual outlier points. So looking at this, honestly, it does not look like a line very much. So in terms of strength, I'm not seeing any sort of strong resemblance to a line. It does not have a strong association with a linear function. So I will note that perhaps it looks like it's generally sort of increasing. So that's the direction. Direction means, is it increasing or decreasing in general? Form and strength, vaguely like a line, but there is really a weak correlation to a line. It asks if there's any outlier points. It's hard to say since it's not really strongly resembling a line. Maybe this one on the bottom here, I don't know, not even. Maybe this one up here, a student who had a very short time on the test and a very high score. This one right here, that might be an outlier. But in general, I don't really see anything that's just wildly different than this big mess of data. So I'm saying there's not really any obvious outliers, but maybe this point here, if you actually go to the Rossmann Chance applet and click on that data point, on the bottom, it tells you down here what that data point is. You have the option of deleting it. It's the point 30, 100. If you thought maybe this one was an outlier, if you click on it, it says that's the point 66, 53. So maybe those are outliers, vaguely. So maybe 30, 100, or maybe point 66, 53. But again, they're not really obviously outliers. Part F, what's their best guess for the value of this correlation coefficient? So Again, this does not strongly resemble a line, so it is not going to be a correlation close to 1 or -1. I think it's going to be closer to 0. Now, I think it vaguely looks increasing, but I'm going to say maybe it's a correlation coefficient of like 0.4. That's my guess. I think it is positive because it looks vaguely like it's increasing. And I think it's closer to 0 than it is to 1. All right, and then it just asks to use the actual applet to see what the correlation coefficient is. So if you go back to the applet here, you will see this box in the bottom right that says correlation coefficient. If you now check the box, it tells me the correlation coefficient is -0.1. So I was off. Notice what that means. The correlation coefficient is -0.1. That indicates that since it's very close to 0, this data set is really resembling just a big mess. It's not associated with a linear function in any sort of way. It's very weak correlation, and it's indicating that the data in general tends to be slightly decreasing. But again, it's very close to 0. When that happens, it is kind of difficult to judge the correlation coefficient, like if it's -0.1 or +0.1, because it tends to look like a scattered mess. I actually thought it tended to be sort of increasing. I think these points over here kind of got my eye thinking it's increasing, but maybe you thought it was decreasing in general. But really, again, overall, it looks like a big mess of scattered mess of points. And that's indicated by the fact that the actual correlation coefficient is very close to 0. One last thing is to please notice what that means in context. In context, this is saying that since there doesn't tend to be any association that we can really see in our sample between test scores and test time, it's kind of indicating to us that there doesn't seem to be a correlation between the time it took a student to take the test and the score the student earned on the test. At least that seems to be the case for our sample. In the next module, we're going to talk about what kind of conclusions to make about a population. But for our sample, since there is such weak correlation between the explanatory and response variables in our sample, I would say that indicates there is very weak correlation between test time and test score.